So I am going to continue the discussion of solutions for the questions in the assignment in friction. So in the previous class, I have discussed the solutions up to question number 42. Now I am going to discuss the solutions starting from question number 43 onwards. Come on, look at the question number 43 on the screen. Block is placed on a rough inclined plane of inclination. Theta equal to 37 degrees. The force to drag it up along the plane is to be smaller than to lift it. The coefficient of friction U should be less than. As I discussed earlier in the special cases for motion on the inclined plane, so when a block is placed on the rough inclined surface of a fixed inclined plane with angle of inclination theta to the horizontal, then the magnitude of the minimum force required to start the block moving up along the inclined plane the magnitude of the minimum value of the force to be applied on the block parallel to the inclined surface in order to move the block up along the inclined plane. So that the block just starts moving up along the inclined plane is equal to mg into sin theta plus nu cos theta. The force required to lift the block the vertical force required to lift the block from the inclined plane against the gravitational force is equal to mg. So the force required to drag up along the inclined plane is to be less than the force required to lift it up the inclined plane. That means mg into sin theta plus nu cos theta has to be less than mg. So you can cancel mg both sides. So sin theta is given to be 37 degrees plus nu cos 37 degrees is less than mg by mg. So sin 37 degrees you can write it as 3 by 5. Cos 37 degrees equal to 4 by 5. That is less than 1. Or nu into 4 by 5 is less than 1 minus 3 by 5. So those who want to copy the solution, they can start copying the solution. So the coefficient of friction between the block and the inclined plane has to be less than 1 by 2. So in case you need more time to copy the solution, you can take a pause and take your time. I am going to discuss the next question. So here, so for question number 43, first option is the answer. Next see the question number 44. The time taken by a block to slide down a 30 degree smooth inclined plane is same as the time taken to slide down a rough inclined plane of inclination 45 degrees to the horizontal and of same length. The coefficient of friction between the block and the rough incline is. Earlier I have discussed a similar question. In the past. So if a body starts from rest and moves with constant magnitude of the displacement covered in time t is given by 6 equal to half t square. So time taken to cover a distance here starting from rest with uniform acceleration A is given by t equal to root of 2s by A. So in both the cases, the magnitude of the displacement is the same and magnitude of the acceleration has to be same. So it will take same time to cover the same distance in both the cases. Only when the magnitude of the acceleration is same in both the cases. So in the first case, it is sliding down smooth inclined plane. As I discussed in the past, the acceleration of the block, when it slides down, smooth and fixed inclined plane with angle of inclination theta to the horizontal under the action of its weight mg and normal reaction by the inclined plane is given by A equal to g sin theta. Here, theta in the first case equal to 30 degrees. In the second case, it is sliding down the rough inclined plane with angle of inclination theta equal to 45 degrees to the horizontal. The acceleration of the block when it slides down the rough inclined plane under the action of its weight mg, normal reaction friction is given by A equal to g into sin theta minus uk into cos theta. But acceleration is same in both the cases. So equate the value of acceleration in the two cases and solve for the value of nu k. Come on, copy down and complete the calculation yourself. You copy down, equate the value of acceleration in the two cases and complete the calculation yourself. In case you need more time to answer the question, you can take a pause and take your own time. See the question number 45. Assertion: it is difficult to move a cycle along the road with its brakes on. Reason: sliding friction is greater than rolling friction. This question was originally given to one of the previous All India Institute of Medical Sciences examination, entrance examination for AIMS. So it is, so when brakes are applied, the wheels of the cycle tends to skid or slide along the road. When no brakes are applied, the wheels will roll on the surface. In general, for given magnitude of normal reaction between two surfaces in contact, the force of rolling friction is less than the force of sliding friction for same two surfaces. So coefficient of rolling into normal reaction less than the coefficient of sliding into normal reaction. So coefficient of rolling friction will be less than the coefficient of kinetic friction or sliding friction. So both the assertion and reason are true, and reason is the correct explanation of the assertion. That means here first option is the answer. Come on, next look at the question number 46. The magnitude of the normal reaction on a block sliding down a fixed inclined plane, nu equal to 0.5. Double the magnitude of the resultant force on the block. The angle of inclination of the inclined plane is. So when the block is sliding down the rough inclined plane, the forces which act on the block or its weight mg which acts vertically downwards So the weight mg of the block acts vertically downwards. The normal reaction force on the block by the inclined surface acts perpendicular to the inclined surface and directed away from the inclined surface. The force of kinetic friction on the block by the inclined surface acts up along the inclined surface. So you can choose the direction of the motion of the block as x-axis and direction perpendicular to the inclined surface as y-axis. So the weight mg of the block can be resolved into rectangular components parallel to the inclined surface and perpendicular to the inclined surface. The component mg cos theta acts perpendicular to the inclined surface. The component mg sin theta acts down the inclined plane parallel to the inclined surface. So y component of resultant force on the block is denoted by Fy. Here N is the magnitude of normal reaction which is direct along positive direction of axis. The component mg cos theta acts opposite normal reaction in the negative direction of axis. So y component resultant force of the block can be written as n minus mg cos theta. But the block has no motion parallel to y-axis. There is no acceleration parallel to y-axis. So Fy is 0. Therefore, the magnitude of normal reaction on the block by the inclined plane is equal to mg cos theta. So, and magnitude of the force of kinetic friction on the block by the inclined plane is denoted by Fk, which is given by nu k into n, which is equal to nu k into mg cos theta. When the y component resultant force is 0, the resultant force of the block is equal to x component of the resultant force. The resultant force of the block is same as x component resultant force. The component mg sin theta acts down the inclined plane along positive direction of x-axis. Fk represents magnitude of kinetic friction which acts opposite to the direction of the motion in the negative direction of x-axis. So magnitude of the resultant force along x direction is mg sin theta minus Fk. You can substitute here Fk equal to nu k into mg cos theta. Next you can take mg common outside. Next it is given that magnitude of the normal reaction force on the block with inclined plane is double the magnitude of the resultant force on the block. Therefore, you can write N is equal to mg cos theta on the left hand side and magnitude of the resultant force from this equation. You can write mg into sin theta minus nu k cos theta. In case you remember the conclusion which I have discussed previously, you can directly write this step. As I discussed earlier, the accelerator of the block sliding down a fixed rough inclined plane under the action of the three forces mg, normal reaction Fk is given by A equal to g into sin theta minus nu k cos theta. So resultant force you can write mass into acceleration, that is mg into sin theta minus nu k cos theta. So this step may be written directly also in case you remember the conclusion earlier, and n equal to mg cos theta. So you can cancel mg both sides. Come on, those who want to copy the working part, come on, copy down the working. because the rest of the part of the calculation is only simplification. Your new K is given to be 0.5. You can cancel mg both sides. And you can solve for theta here. So double the resultant force means into 2 you have to write here. Come on, copy down the working. This problem was given one of the previous entrance examinations. Same model problem was repeated twice in the past entrance examinations. In EAMCET. And also same model problem was given one of the previous all-India entrance examinations. So finally you can arrive at the conclusion that tan theta equal to 1 or theta equal to 45 degrees. So the angle of inclination of the inclined plane to the horizontal is 45 degrees. So in case you need more time to copy the solution of the problem, you can take a pause and copy down the solution of the problem. So for question number 46, first option is the answer. See the question number 47. Block of mass 10 kg slides down a fixed inclined plane of inclination 30 degrees to the horizontal with acceleration of 2.9 meter per second square. What is the magnitude of the force to be applied parallel to the inclined surface in order to move it down along the inclined plane with an acceleration of 7 meter per second square? So in the first case, it is sliding down the inclined plane under the action of its weight mg and forces by the inclined plane. So in the first case, the forces which act on the block or its weight mg acts vertically downwards, which is the gravitational force of the block by the earth. Then normal reaction force on the block by the inclined surface acts perpendicular to the inclined surface and directed away from the inclined surface. The force of kinetic friction on the block with the inclined surface acts up along the inclined surface, opposing the motion of the block relative to the inclined plane. Can resolve the weight mg into rectangular components parallel to and perpendicular to the inclined surface. The component mg cos theta acts perpendicular to the inclined surface. The component mg sin theta acts parallel to the inclined surface down the inclined plane. The block has no motion in the direction perpendicular to the inclined surface. Therefore, magnitude of the resultant force on the block down the inclined plane parallel to the inclined surface can be written as mg sin theta minus fk. Fk represents magnitude of kinetic friction on the block. From Newton's second law, magnitude of this resultant force of the block is equal to product of its mass and acceleration. So you are given the mass of block as 10 kg. Theta is given to be 30 degrees. The magnitude of the acceleration is given as 2.9 meter per second square. G is given as 9.8 meter per second square. So substitute all the values here. And simplify it yourself. Come on, you can start copying this working part. You can take sine 30 degrees equal to 1 by 2. So you can simplify this to find magnitude of kinetic friction of the block by the inclined plane. So you get magnitude of kinetic friction of the block with inclined plane as 20 newtons. So in the second case, the problem is not completed. It is to be continued on the next page. If you finish copying this solution up to this step, then we can discuss the next case or second case. But you have to remember that in both the cases, magnitude of kinetic friction of the block by the inclined plane has same value equal to 20 newtons. Because in both the cases, the block is sliding down the same rough inclined plane. So in the second case, I've shown the situation in the figure in the second case. In the second case, you are asked to find magnitude of this force capital F, which has to be applied on the block parallel to the inclined surface, down the incline, so that the block moves down the inclined plane with an acceleration of magnitude 7 meter per second square. So the weight mg, just like in the earlier case, here also can resolve the weight mg into rectangular components parallel to and perpendicular to the inclined surface. The component mg cos theta acts perpendicular to the inclined surface. Opposite narrow reaction. The component mg sin theta acts down the inclined plane parallel to the inclined surface. Fk represents magnitude of kinetic friction of the block which acts up along the inclined plane. So magnitude of the resultant force on the block down the incline in the second case. We are continuing the solution of question number 46. So magnitude of the resultant force on the block down the inclined plane, you can write mg sin theta plus capital F minus Fk. From Newton's second law, this resultant for the block can be equated to product of its mass and acceleration. Therefore, magnitude of the force to be applied on the block parallel to the inclined surface down the inclined plane, to move it down the inclined plane with an acceleration A, will be equal to ma plus Fk minus mg sin theta. Here the mass of the block is given to be 10 kg. The acceleration of the block in second case has to be 7 meter per second square. Magnitude of kinetic friction of the block in the second case same as the magnitude of kinetic friction in the first case. So in the previous case, magnitude of kinetic friction is equal to 20 newtons. So again, it has to be 20 newtons. It will be 20 newtons again. Mass of block is 10 kg. G is 9.8 meter per second square. Sin theta equal to sin 30 degrees. So this you have to simplify it. Come on, copy it down. You can substitute sin 30 degrees equal to 1 by 2 and simplify it to yourself. Okay, రాయలేదా మీరు? So you can simplify it yourself. You get 41 newtons. Come on, copy down solution of the problem. In case you need more time to copy the solution of the problem, you can take a pause and take your own time. So the question which I have just now discussed, it's not the question number 46. I'm sorry, it's the question number 47. I have put the wrong number there, but the solution is the same for question number 47. 46 I have already discussed earlier. So the question which I have just now discussed is the question number 47. So for the question number 47, third option is answer. That is 41 Newton. So next I am going to discuss the question. Look at the question number 48. UK, comma, US and UR denote the coefficients of sliding, comma, static and rolling friction respectively. The ascending order of the coefficients of friction between the two given surfaces is. So as already discussed, that coefficient of kinetic friction or sliding friction is less than the coefficient of static friction, and coefficient of rolling friction is less than the coefficient of sliding or kinetic friction. Therefore, the ascending order of the values of coefficients of friction between two given surfaces, nu r, comma, nu k, comma, nu s, or nu r less than nu k. In case sometimes some of the questions you may be asked to find the descending, you may be asked the descending order. In case you are asked the descending order, you can write like this: nu s greater than nu k greater than nu r. It's a theoretical question. So for the question number 48, fourth option is the answer. See the question number 49. A box is placed on an uniform plane and the inclination to the horizontal is gradually increased. The box just begins to slip when the inclination to the horizontal reaches 37 degrees. Slides 4 meters down the plane in 2 seconds, starting from rest. What are the coefficients of static and kinetic friction between the box and the plane? So as I discussed in the theory path of the motion down the rough inclined plane. So when a body is placed on a uniform plane, and if inclination of the plane to the horizontal is gradually increased, then the body just begins to slide down the inclined plane when the angle of inclination just exceeds the angle of repose. The angle of repose is the maximum angle of inclination of the inclined plane to the horizontal, for which the block just stays in limiting equilibrium. The angle of repose is same as the angle of friction between the two surfaces in contact. So the block or body placed on the rough inclined surface just begins to slip down the incline when the angle of inclination of the inclination to the horizontal, then the angle of inclination of the inclined plane to the horizontal just exceeds the angle of friction between the two surfaces. So in this case, it is given that the box just begins to slip when the inclination reaches 37 degrees. That means you can assume that the angle of friction is infinitesimally little less than 37 degrees. By small amount or angle of friction can be really taken as equal to the 37 degrees. The angle of friction can be written as tan inverse nu s, where nu s is the coefficient of kinetic friction between the two surfaces. Therefore, tan inverse nu s is 37 degrees, or nu s is equal to tan 37 degrees. That comes out to be about 3/4 or 0.75. That is one of the answers. To find the question of sliding friction between the block and the rough inclined plane, you have to know the acceleration. So given that the block slides down the rough inclined plane, a distance of 4 meters in 2 seconds, starting from rest. That means it covers a displacement s equal to 4 meters in a time interval t equal to 2 seconds starting from rest. So if a body starts from rest and moves with constant acceleration, the magnitude of the displacement covered in time t is given by s equal to half at square. Here s equal to 4 meters and time t equal to 2 seconds. You can simplify this yourself. You get magnitude of acceleration 2 meters per second square. The magnitude of the acceleration of the body when it begins to slide down the inclined plane is given by A equal to G into sine theta minus nu k into cos theta. Here theta is 37 degrees. So you can substitute A equal to 2 meters per second square on the left hand side and G equal to 10 meters per second square on the right hand side. Sine 37 degrees equal to 3 by 5 and cos 37 degrees equal to 4 by 5. Come on, copy down the solution of this problem. Copy down the solution of this problem. In case you need more time to copy the solution of the problem, you can take a pause and take your own time. This can be simplified by yourself. So finally, you will get question of kinetic friction between the box and the plane as 0.5. That is the other answer. So for question number 49, which I have just now discussed, first option is answer. See the question number 50. A wooden box is kept at the middle of a table of length 4 meters. The coefficient of friction is 0.5. The table starts accelerating at 5.9 meter per second square from rest. The time needed for the box to fall down the table is. So the table starts moving towards right. So the acceleration of the table I denote by A subscript T. This problem you can solve by two methods. One method is you can solve the problem with respect to the accelerated frame of reference fixed to the table. So the other method is you can also solve the problem with respect to laboratory frame of reference. So first I solve this problem with respect to the accelerated frame of reference fixed to the table. So I am going to draw the free body diagram for the box with respect to the accelerated frame of reference fixed to the table. So there are two forces that act on the box in the vertical direction. One is its weight mg, which is the gravitational force on the box by the earth, which acts vertically downwards. And the normal reaction force on the box by the surface of the table acts vertically upwards perpendicular to the surface of the table and directed away from surface of the table. So here the table is moving towards right relative to the box. the table is moving towards right relative to the box. So force of sliding friction on table. So velocity of the table with respect to the box directed towards right. So force of sliding friction on table by box opposes the velocity of the table relative to box. So the velocity of the table relative to box is towards right side. Therefore, the force of friction on the table by the box is directed towards left side. I mean, force of kinetic friction on the table by the box is directed towards left side. From Newton's third law, the frictional force on table by the box is directed towards left side. Then the force of friction kinetic friction on box by the table acts towards right side. So these two forces form action reaction pair. But when you are drawing the free body diagram for the box, in the free body diagram for the box, we must show only the forces acting on the box. So these are the three real forces which act on the box even with respect to laboratory frame of reference. But if you analyze the motion of the box relative to the table, that means we are drawing the free body diagram for box with respect to table. So the frame of reference fixed to the table is moving with an acceleration of magnitude at towards right. So this frame of reference is an accelerated frame of reference. Therefore, with respect to the accelerated frame, in addition to these three real forces, there will be a pseudo force on the box. The magnitude of pseudo force is called a product of mass of the box and magnitude of the acceleration of the table, which acts towards left side. So A subscript small t represents the magnitude of acceleration of the table. So the box has no motion in the vertical direction. So y component of resultant force or vertical component resultant force is 0. So magnitude of normal reaction on the box by the table, you can take it as mg. So magnitude of kinetic friction on the box by the table is equal to nu k into m or nu k into mg. So here nu k is 0.5. So we'll substitute numericals next step. So now the table is moving towards right relative to the box. So the acceleration, here the magnitude of the resultant with respect to the box table is moving towards right, or with respect to the table, you can say box will be moving towards left side. So the resultant force, let us choose the direction towards right as positive direction of x-axis, vertical upward direction of y-axis. So resultant force on box with respect to table, with respect to accelerated frame, is equal to x component resultant force, that you can write Fk into Fk minus mass into acceleration of the table. From Newton's second law, this must be equal to product of mass of the box into magnitude of the acceleration of the box with respect to the table. So small a subscript b comma t represent the accelerator of the box with respect to table. So here Fk equal to nu k into mg. So you can divide this equation with mass m. So accelerator of the box with respect to the table. You get nu k into g minus accelerator of the table. So nu k is given to 0.5. G is 9.8 meter per second square. The accelerator table is 5.9 meter per second square. So accelerator of the box with respect to the table. This you can simplify it. You get minus 1 meter per second square. The negative sign indicates that the accelerator of the box with respect to the table is directed in the negative direction of x-axis. That means accelerator of the box with respect to the table directed towards left side. So when the table is moving towards right with respect to a laboratory frame of reference, then with respect to the table, the box appears to moving towards left side. The length of the table is given as 4 meters, and it is given that the box is kept at the middle of the table. That means the box will fall from the table and magnitude of the displacement of the box relative to table is 2 meters, half of the length of the table. So the box is initially at the middle of the table here. That means distance of the box from each edge of the table will be half of the length of the table. This is the surface of the table here I have shown. Of course, I have not shown the legs of the table. They will be present, but I have not shown in the figure. So the box with respect to the table, the box appears to move towards left side. So the box will fall down the table when magnitude of the displacement of box relative to the table is 2 meters. So for relative motion, so magnitude of the relative displacement of box with respect to the table is equal to half into magnitude of the relative acceleration of the box with respect to table t square. Initially the box is at rest with respect to the table. So initial velocity is 0. So the body starts from rest and moves with a constant acceleration. Then magnitude of the displacement in time t is given by equal half a t square. So magnitude of the relative displacement of box with respect to the table is 2 meters here. Magnitude of the relative acceleration of the box with respect to the table is 1 meter per second square. You can simplify this. So if you simplify this, you will get t equal to seconds. So the time needed for the box to fall down the table is 2 seconds. So 2 seconds is the answer. So in case sometimes you can be given the same question and you may be asked what distance the table travels when the box falls from the table. So this is the answer for the question that I have given, shown on the screen. In case you are asked to find magnitude of displacement of the table when the box falls from the table, that is equal to magnitude of displacement table equal to half into magnitude of acceleration of the table into t square. That is half into acceleration of the table is 5.9 meter per second square into 2 square. That you can simplify it. So I am going to next solve the same question by the alternate method, that is with respect to the stationary observer on the ground, means with respect to laboratory frame of reference. Those who, if in case you need more time to copy the solution of this problem, can take a pause and take more time. So next I am discussing the same question, that is the question number 50, by the alternate method. That means we are solving the problem with respect to the stationary observer on the ground. I mean, we are solving the problem with respect to laboratory frame of reference, which we consider to be inertial frame of reference. So this is a free body diagram for the box with respect to lab frame. The weight mg of the box acts downwards, normal reaction acts vertically upwards. As explained in the previous method, when the box, the table, AT bar is axillary to the table, which is directed towards right side. So when the axillary to the table is directed towards right side, the force of friction on table by box acts towards left side. As explained in the previous method, force of kinetic friction on the box by the table acts towards right side. That means with respect to laboratory frame, the box is also moving towards right side. So Fk is the magnitude of kinetic friction on the box by the table, which is directed towards right side. So I come again following the repeating the same procedure, you can write magnitude of kinetic friction on the box by the table in UK into mg. So resultant force on the box with respect to laboratory frame of reference, I mean with respect to stationary observer on the ground, is equal to Fk, that is equal to mass and acceleration. We can write Fk equal to UK into mg, that is equal to MET. So AB is the magnitude of actual acceleration of the box. Means AB is the magnitude of acceleration of the box with respect to stationary observer on the ground or with respect to laboratory frame of reference. Here nu is given to be 0.5, G is equal to 9.8 meter per second square. So magnitude of actual acceleration of the box with respect to laboratory frame is 4.9 meter per second square. So magnitude of acceleration of the box is less than the magnitude of acceleration of the table. So the table is moving more faster. Magnitude of acceleration of the table is given as 5.9 meter per second square. So table is with respect to stationary observer on the ground, table is moving towards right with an acceleration of 5.9 meter per second square. Whereas box is moving towards right in the same direction with an acceleration of 4.9 meter per second square. So the box falls from the table when magnitude of the displacement of the table minus magnitude of displacement of the box, difference becomes equal to 2 meters. Magnitude of displacement of the table is equal to half into magnitude of acceleration of the table into t square. Magnitude of displacement of the box is equal to half into magnitude of acceleration of the box into t square. Now we can substitute the magnitudes of accelerations of table in the box and simplify it yourself. You get the same answer again. If you want to copy down this alternate method also, you can copy down and complete the calculation yourself.